Okay. Hope everyone can see my screen. So I'll go through the slides, and then if you have any questions, you can just drop them on the chat box. My colleagues here will attend to them, and some of the questions we can I'll respond to them at the end of the presentation. So the Huawei residential sector. The Huawei residential sector. It's mainly caused the Fusion Solar Residential Smart PV solution. This comprises of inverters which are less than 10 kilowatt. So you've got the single phase and then you've got the three phase. The single phase, you have got 2 to 6 kilowatt transformerless inverters, and then for the three phase we have got the 3 to 10 kilowatt. However, currently only the 6 kilowatt has been approved for NRS, that is to be sold in our region, and then the three phase we are working on that, such that we can have some of the three-phase residential system available in our market as well. So our presentation mainly will be focused on the single-phase 6 kilowatt, which is the product that we already have. We have got a couple of installations which are already running out there. So I'm sure everyone knows about Kathia Energy. For more info about us, you can go to our Kathia website, www.kathiaenergy.co.za, for our product range. And if you want to access the portal, there will be links there. So our Huawei residential range, as I've said, will be mainly focusing on the single phase 6 kilowatt. So this is a transformerless inverter. By design, this inverter is a pure grid tie. So we all know every grid tie inverter has got only one port. Okay, just a second. Okay. Okay. Sorry. Are you having on your side? Is it a full screen or? Okay. I'll just stop sharing and then reshare my screen. Since some guys are having issues with the screen. It's not okay. Okay. Okay, just okay. Yeah, as I was saying, okay, as I was saying, Huawei inverters, it's a pure grid tie inverter, with quite a lot of protection, as you can see on our top left. The inverter is okay. Just hold. Can you mute your? Please make sure that all your mics are muted. Okay, yes, yeah. So the inverter has got quite a lot of protections for grid tie inverters, as you can see on our top right. All those are the protection features that comes with the inverters. So all the there's a built-in arc protection, your battery reverse, it's anti-islanding and all those features, and then it has built-in DC and AC surge protectors with it. I'm sure much of the stuff was covered in our previous webinar on product overview. And then we have got our battery, our storage system, which is called the Luna 2000. So the battery comes, it's a high voltage battery. So it comes with a power module. So we've got what we call a battery module and a power module. So the battery module is the actual battery with the cells which store charge and all that. And then the power module is there to provide, since our battery system is a high voltage battery, that it needs a power module to interface it to the inverter. So the nominal voltage of the battery module, it will be a 51.2 volt like a normal battery, but the battery module is responsible for stepping up that voltage to around 600 to 900 volt, which is the operating range of the of the system for the inverters. So for every installation, definitely you would need a battery module. One battery module, a power module. One power module can takes up to three battery modules. So you can build up to 30 kilowatt of your battery system in multiples of 5, since one battery module is 5 kilowatt. So the battery depth of discharge, it's 100% depth of discharge when you are in grid mode or hybrid mode. And then when you are now in pure off grid mode, then the battery depth of discharge automatically goes to 85%, reserving 50, such that the inverter doesn't shut off completely when you're on off grid, right? And then so the battery, as I've said, each battery module is 5 kilowatt pack, which is a 0.5 C. So it means continuously you can draw up to 2.5 kilowatt at a given time. And it can supply a peak power of up to 3.5 kilowatt for 10 seconds. So for all your starting currents, if you have got pumps, inductive loads, then the battery will be able to surge power up to 3.5 for 10 seconds. If it exceeds that, then it will trip, since the rated power drawn from the battery should be 2.5. If you have two battery modules, then you double up all the specs. So your storage will be 10 kilowatt hour, 5 kilowatt discharge, discharge at a given time, and then a surge power of up to 7 kilowatt for 10 seconds. And then and then if you add more batteries, the third battery, to make it 15 kilowatt, your discharge power will go up to around 7 kilowatt to cater for a 6 kilowatt inverter, and the surge goes up to 7.5 for 10 seconds as well. So even if you have got 3 batteries, you cannot draw more than the size of the inverter, which is 6 kilowatt. The inverter is the one that will limit you to 6 kilowatt. So for communication, for remote monitoring, for the site, the Huawei inverters, they use a smart dongle 4G. So you can actually get a 4G card and plug it in. Then the 4G dongle will be the one responsible for your remote monitoring on Fusion Solar app and website. And then the system also supplied a WLAN FE, which is a fast Ethernet. So you can get a smart dongle, a VLAN FE. So you can just wire your Ethernet cable from your router straight to the unit, and then the VLAN FE dongle will be the one responsible for uploading data to the Fusion Solar. So the VLAN dongle can control up to 10 devices on your network. So if you have got all your devices that will be there, will be limited to 10. And then our system supports optimizers. It's a spatial optimization. It's not mandatory to wire optimizers, but since you are in the residential sector, usually there is a lot of issues of shedding from trees and all that. So the system supports optimizers. So currently the optimizer that we have in the market, it's a 4-watt peak optimizer, plus or minus 5% tolerance. But however, we are looking to have a bigger optimizer, 2-in-1 optimizers, probably by end of Q4 to next year Q1. So optimizer brings in a module level monitoring, module level shutdown with a rapid shutdown of less than 5 seconds. Then your string output will be 0 volts. So the shutdown voltage for the optimizer is 0 volts. So if you are troubleshooting, the optimizer offers a resistance check, which is 1 kilo ohm per optimizer, plus or minus 10% tolerance. So if you have a string with 10 optimizers, if you want to check if your string is properly configured, then you would measure resistance. So that would be a total of around 10 modules, that's 10 kilowatt plus or minus 10%. And then the output of the optimizer will be always 0, which is safe operation voltage, in case whenever the inverter is off, then the optimizer will output 0 for protection. So the optimizer can actually help you for long string designs. Since you have got an ESS system on the system, it's a 6 kilowatt system. There is need to charge your battery at the same time you are supplying your loads in case during daytime. So if you have an optimizer, you can wire strings up to 10 kilowatt watt peak on a 6 kilowatt inverter. So that gives you enough power to charge your batteries at the same time to supply while you are supplying your loads as well. So the optimizer helps you for long string design as well. And then the optimizer design, it's quite small, probably 50% to the standard optimizer that has been there in the market, which is palm size. You can just hold it and easy to mount and all that. So for monitoring purposes and configuration, Huawei inverters, residential inverters, they utilize the Fusion Solar. So I've got the Fusion Solar app, which you can download on your Android or iPhone phone. So the app is the one that we use for configuring the system. One of my colleagues will take you through the process on our next slides, which is the main agenda for today's webinar. And then for monitoring, you can use your phone, or alternatively, you can monitor on the website, on the Fusion Solar website. So just a roundup, I know much of the stuff we covered in our previous webinar. So these are the main features for our Huawei residential system. So Huawei inverters, they're built in with artificial intelligence arc protection. So the system continuously learn its surroundings in terms of arcs, because arc is one of the major problems that we face in the PV industry. These are high power systems. So if a string is not properly terminated, or there is a positive to ground, negative to ground arcing, that could cause fire. So the system would continually learn its surroundings in terms of current thresholds of installation and all that. And then whenever there is an arc which is out of this normal operating conditions, then the system will automatically shut off. And then if you have optimizers, then the output 0, and then your strings will be your strings will be there, then it extinguishes the fire. If you don't have optimizers, then the inverter will stop producing, and the demand from PV will be stopped. Hence the modules will be floating, and that will also extinguish the arc. And then when you have got optimizers, you can actually pinpoint the arc fault positioning. It can actually pick the exact panel or string which is giving that arc, so that cuts down your O&M time and cost. And then, as I've said, the inverters, they are touch free, 0 module level voltage shutdown, which is safe for our household and personnel on site. And then the optimizers, they increase the efficiency of our system. As you know, with optimizers, each module works independent. As you all know, modules connected in a string, they work at the least efficient. If you have a string of 10 modules and one module is shedding, then it affects the whole string. Unlike when you've got the optimizers, then if one module on a string has a shedding, then only that module will be affected while other modules will be producing to maximum. The system has got a battery ready. So this, as I have said, this is the inverter is a pure grid tie. So it gives you the flexibility to introduce an ES system to your grid tie system. So you can have a grid tie system with battery. During daytime, you can supply your loads in real time and charge your battery. Off the sun, then your grid tie inverter can take from the battery and supply your loads. But in a grid tie scenario, the moment you lose the grid, then the inverter will be off, and then you can configure the system as a hybrid or off-grid. We'll look into that shortly as well. One size fits all optimizer. So one optimizer is compatible with all the Huawei inverters. So if you have a different inverter, it's not mandatory that you need to have a specific optimizer on that. And one other thing is partial optimization. It's not mandatory to have all optimizers on all the strings. If you have one section of your array which is affected by shading, you can just have that section with optimizers Y to the first MPPT, while the other MPPT is working without the optimizers. And then Huawei offers a module auto mapping. So if you have your optimizers, or you can just scan the QR codes, set up a template on how your panels are laid out on the roof, and then by scanning the QR code in less than 5 seconds, then it can actually populate your system view, right? And then as you all know, all our Huawei inverters, they are touch free. No quick way parts, because the quick way parts, they're a point of weakness. Useless string design, there are no patterns, no screen, because all those things, they are point of weakness. No fans, they use natural air cooling, so you won't get so it increases the inverter availability of the system. You won't get to say the fan is not running, the inverter is not working, or the pattern is no longer, you can no longer press the pattern and you cannot configure. All the configuration on the Huawei inverters is done through a web-based page or through an application. So the internal structure of our residential inverter, it's a two-string input on an MPPT. So the system has 2 MPPTs, and then you've got one string per MPPT. So you've got your positive. Internally, the system will bond the negatives, and then the positive will be pushed through together to the filter through an SPT, which is built in, and then to a central DC bus where your battery will be connected as well. And then on the output side, we've got an AC SPT inbuilt as well, so that the system can be protected in terms of searches. All the DC and AC SPTs, they are of type 2, so which works fine with our region. And then system overview, which is the SLT of the system. So this is the complete SLT of the system. So the system, you would have your batteries going to the inverter, your positive and negative. And then you've got your panels, which is DC as well, which you pass through a DC protection box, through which is not mandatory, and through the DC switch built in on the inverter, and then to the MPPT circuitry, to the internal MPPT circuitry. And then the AC line from the grid, you would need to install a power meter. So this is a system that works with a grid. So there is need to monitor our export. in regions where you're not allowed to export, you need to monitor your grid tie-in point, so that you won't feed back to the to the grid. And then through from your meter. So your meter is supposed to be installed right at your mains incomer, because it is the one which generates the set point for the inverter to produce, right? And then from there you can go to your non-essential loads. In this part, we've got our house DP denoted by ACDU. On our right with a load. So these are non-essential loads. These are high power loads that you wouldn't want to drain your battery during load shedding. And then the system comes with a backup box. We look into detail on the system setups. So the backup box is a separate unity. So the inverter is a pure grid tie. And if you intend to configure it as a hybrid inverter, it's just that when you lose grid, then the system will be able to supply a certain section of the house, because by NRS specifications, whenever for every grid connected inverter, the moment it loses grid, it's supposed to anti-lane. That is, it's supposed to stop producing, because it might feed back to the mains lines. So the backup box is responsible to make sure that our grid tie inverter doesn't switch off, but it cuts out the grid line, which is the non-essential loads, which is the high power loads, and then the grid line, and then only focuses the power from the inverter to essential loads denoted by important load on the diagram. So we'll quickly have a look on the individual setups of the system, how they'll be wired. So first we'll look at grid-tied ESS solutions. That is, all our loads, they are one. All loads in this scenario, they'll be non-essential. So when you've got inverter and batteries, one inverter and batteries, so you'd have your batteries either one pack or two pack, wired to your inverter with your PV strings to the inverter. And then all the loads they are non-essential. This is basically a grid tie system with a battery setup. So during the day you get your PVs, they supply power to the loads. If there is enough excess from the PV, then you charge your battery. At night, then your system will take from the battery and supply the whole house with power from the battery. If the batteries run flat or runs short, then the grid will be there to supplement the balance, and then the meter will be there to monitor your import and export. And then the second scenario, in case where you've got two inverters, and then you've got only one inverter with the battery. So this will be the wiring setup. So your battery just wired to one inverter. So the other inverter will be taking straight for the grid line. So the other inverter will be just a pure grid tie without battery, while the second inverter is a battery backup. So in cases of off the sun, then the inverter with the battery will just take power from its battery and supply it to the load network. The one without battery, since it won't be having PV, then it will be just on idle mode, waiting for PV to come up. So this is a grid tie scenario. So all loads that interface to the inverter, so the battery will be just pushed to the wall house. So this is basically a setup where you would want a grid tie inverter. You have a semi-reliable grid, and then you would want to have a buffer to store your excess PV during the day, and then use it at night, so as to cut down on your grid consumption. And then when you've got two batteries as well, so the second inverter will just be hooked with two batteries, and then an interface to the same load network. So this is the working mode that I was talking about. So during the day, when you've got enough sun, then you can get PV, supply all your loads, because they are all interfaced as one. And then some of the power charging the battery. That is our top left image. On our on our top right image, when the PV is not sufficient enough to supply the loads, then the inverter will take all the power from the PV, supplement with the battery to cater for your loads. Bottom left, in cases where you've got excess PV and you're allowed to feed back, then you can charge your battery with maximum power, which is 5 kilowatt charge and discharge power for the battery, and then 2 kilowatt supply your loads. When all your loads and battery are catered for, then the excess will be fed back to your grid. At night, or when the PV is not sufficient enough, then the system will take from the battery, supply your loads. If there is deficiency, then it will pull that power from the grid, which is basically a normal grid tie inverter. But this one, you can interface it with a battery solution. And then the second scenario is a grid-tied and off-grid ESS networking. So this is the scenario that mostly we are looking for, to say when you have got grid, then the system will operate and supply all sections of our premises with PV and battery. And then in case of a load shedding, since by design a grid tie inverter will switch off, but in this case, you would want to focus power to a certain section of the house where you've got your essential loads. So you've got one inverter with battery, then you've got your setup, and then power coming from the grid. Your meter measures the whole premises before you supply everything, because the meter is the one which is responsible to give the set point for the inverter to produce. So the meter positioning is quite important in hybrid scenarios. And then after the meter, then you supply your non-essential TP, which is your high power loads, your stove, your geysers. So in this case, you are not worried about overloading the inverter or with the loads. But in this case, these non-essential loads, we don't want them to drain our battery in cases of load shedding, because you can't be in the darkness just because the geyser was pulling power. So those loads are considered as non-essential. And then you've got your backup box. The backup box now splits between your essential and non-essential. So when you have your grid running, the backup box will give a pass-through. So it will take power from the battery and the panels, supply both essential loads and non-essential loads, and then the meter monitoring your import export. The moment you lose the grid, the backup box would cut out the non-essential loads, and then just pass through power from the batteries to the essential loads. And then if you have got two inverters, one inverter with the battery backup, while the second inverter it's a pure grid tie, then the backup box will be wired on the inverter that has got battery. So in cases of so both inverters, when there is grid, they will push PV, the one with battery, add battery as well to the network, and then supply both essential and non-essential loads. But the moment you lose grid, then your grid tie inverter will switch off, and then the one with batteries, which is in hybrid mode, then will continue to supply the essential loads only. But the one with batteries is not able to give reference to the grid tie one, such that it can produce even if you have grid, if you don't have grid. So the moment you lose grid, the inverter without the battery will switch off, while the one that is while it's the one that is a backup box, then will keep powering your essential loads. And then if you have got two inverters and all of them, they've got batteries linked up to them, then each inverter has to have its own separate HV box, because the HV box is the one that will determine whether it's grid mode or off grid mode, and then give a signal to the inverter such that it knows that it now operates in off-grid mode or in hybrid mode. So each inverter would have its own separate HV box, and the output of the inverter will be pushed to your different sections of your essential loads. And then this inverter can be wired as a pure off grid, totally without grid. So since we don't have a grid, all our loads, they are always what? They are always essential to our systems. So there is no need for a backup box in this scenario. So you just have your inverter, you wire them to your loads, and then you've got your PV and battery network to the system. So when you're in pure off-grid mode, you are not allowed, you cannot use optimizers. Why? Because if you have optimizers, if it happens that your battery is drained flat, that inverter will never come on. Because when your battery is off, so it means the inverter would need to power on from the what? From the panels when the sun comes up. Now, if you have got optimizers, the inverter is the one that switches on optimizers through M-bus communication. So it means if you have got optimizers, the optimizers won't switch on, will be waiting for the inverter to give a command. While the inverter is off and the battery is empty, so the inverter, since you don't have any alternative source between the two, then the inverter, it means it will stay off. So in pure off-grid scenario, you don't need a backup box, you don't need optimizers. So your battery, definitely you would need your battery network, your battery setup. So if it's at night, your batteries get depleted, and the inverter happens to switch off, or even on initial start up, you would need the panels running. So the panels, they will produce string power to the inverter, and then the inverter will power on, and then from there it can charge the battery. So that's how you can set up the system on off grid. So this Huawei system is quite flexible. It's not rigid because you all know hybrid inverters, they are a bit pricey compared to grid tie inverters. So the system gives you the freedom to get a grid tie inverter. If you know that you have got a reliable grid and you are looking at having a battery solution for your grid tie inverter to cut down on your ESCOM consumption, then you can get the inverter, get the batteries, and then the system will get PV to supply loads during the day, which is a normal grid tie setup. At night, then it can use power stored in the batteries to push to your load, and then you'll be self-dependent in terms of power, and then you can cut down power from ESCOM. Basically, you can configure a system where your grid is your backup in this scenario. And then if you want to configure the system as a hybrid, then you can get a separate unit. So a normal hybrid inverter that is in the market, that system, that backup box is already built into the inverter, and then the inverter gets pricey. Right. So for guys who would want to use a grid tie inverter with battery, it becomes pricey to buy a hybrid inverter. Right. So so if you now want to put a hybrid, then you get a backup box unit. Unfortunately, the current backup box in the market at the moment, it has a 2-second delay, max 1.5 to 2-second delay max. However, Huawei, they are now on the testing phase of the millisecond changeover, with an average changeover of 10 milliseconds for the NRI certification. So definitely, probably will be having the millisecond changeover at end of Q4 to Q1 next year. So with the backup box, then you can build a hybrid system with the two units. And then if you want an off-grid inverter, then you can just get the inverter with your batteries and panels. There is no need for a backup box and optimizer. So, and then the optimizer is not mandatory. So it gives the flexibility to design your system. You might have a clear array facing a clear array without shedding, and then some part of the array with shedding. So you can just get your optimizers, concentrate them on the areas that they've got shedding, and then the other string, then you can just wire it without optimizers. So it offers that feature for partial optimization, and it's optional. So as you see from all the setup for remote monitoring, then you can use a VLAN dongle FE, or you can use a 4G dongle. And then now we have got a VLAN dongle as well. But the Huawei residential range, they come in built in with a VLAN network. So you can actually use the inverter VLAN network to connect to your Wi-Fi, and then you can connect to the server. So the backup box, so a backup box is a separate unit basically for switching, that is grid mode, off grid mode. So it's the inverter by design, it has got one port just like a normal grid tie inverter. So the backup box offers those other sections such that you can have your grid input port, your load output port. So since this backup box needs to be connected to inverter, then it has a third port, which is the inverter port. So unfortunately, my image is not that clear. I didn't realize that. Sorry about that. So at the bottom where it's highlighted X1 on image number 3, where it's highlighted X1, so that is the load port. That's where you would wire your essential loads, which is the loads that you would want to get power in case there is a load shedding. And then next to X1, there is a second block connector, which is the grid termination point. The, on the below images, the block connectors have got 1 to 11 blocks. So you'd wire your grid on 2, 6, live 2, neutral 6, and then earth on 10. That is your grid, your cables coming from your grid line, which is the same line that supplies your non-essential loads. And then you've got a third block connector on the right, which will be the inverter connection point. So on the inverter connection point, you basically wire your live, neutral, and earth. That goes to your inverter point for which is the normal grid point on a grid tie inverter. And then the backup box needs to communicate with the inverter. So it gives an enable signal in case the grid. So the inverter is a grid tie, so it will use the grid to power on and get reference to produce, right? So the moment it loses grid, is supposed to switch off, right? So the backup box, the moment the backup box loses ESCOM, it would detect to say, okay, we have lost grid, and then sends an enable signal to the inverter, basically to tell the inverter that currently we don't have grid. Can you use the battery to power yourself up? Then the system would then use the battery to power itself off, and then becomes in a semi off grid mode, and then start giving out power. So that signal. So this is the underneath of a single phase residential inverter. As you can see highlighted on your right, you've got your inverter termination point, which is where you wire your live, neutral, and earth. Next to it, you have got a COM port. It's a plug-in. So the pin layout, they're the ones at the bottom. So you've got your pin layout. So the backup box, it has got a ground and a positive signal, which is a digital input. So your ground, you wire it on 0.5 on the inverter, and then the positive of the signal, which is the digital input, then you wire it on 0.8. So the signal will be always low, and then the inverter operates in grid tie mode. The moment the backup box loses grid, sends a digital input signal of 0.8, then the inverter would know that the grid is off. But on my connection, I have a backup box which is able to split the grid and the essential loads. So from there, then the system can now get a go ahead to to use the battery to power on and supply the section of the essential side. And then so this is the wiring setup. So one inverter can take up to 30 kilowatt of battery power. So one power module can control a maximum of 15. So if you've got your battery backup is more than 15 kilowatts, so you would need 2 power modules. So these power modules, they will be parallel together. And then there is a COM setup wiring for the batteries. And then from the one of the power module, you go from one power module and then you go to the inverter. So from the battery, we have got enable signals, and we have got the communication. So for enable signals, for enable signals, as you can see from our left, it's point 2 and 4. Then they'll be wired to the inverter, right? And then we've got I'll show on our next slide where they'll be wired exactly. And then you have got our RS-485, which is the normal communication. So the inverter and the battery, they use RS-485 for communication. So the communication, you'd wire them to an RS-485 point on the inverter. So you just daisy chain it together with the power meter on the RS-485 port, and then between the batteries, the communication between the batteries, it's a CAN bus. So between the batteries, then they would communicate through CAN bus, and then between the batteries and the inverter, they will communicate through RS-485, which you can daisy chain together with a meter if you are export limiting. And then you would need to wire the enable signals to the inverter. Since on my previous slide, I specified that when you release grid, the backup box will send an enable command to the inverter. And then the inverter, when it knows that it is a backup box, even though there is grid, it needs to power on, then it will send an enable signal to the battery such that the battery can power off, and then it can supply the non-essential loads even during load shedding time. So this is the pin layout for the battery and the inverter. So your RS-485 A and B 2-wire system, you wire them on point 3 and 4. So from our connector, RS-485 is point positive is 4.5 on the battery, and then negative is 6.7. So you can use either of those, and then you'd wire them to point 3 and 4, which is B and A respectively on the inverter block connector. And then 5 is ground. So your enable signals, you've got your enable positive and your enable negative. Enable negative, which is ground, right? So the enable negative, you would ground it on 0.5, which is the same point where you grounded your backup box. And then enable positive, which is 0.3 on the inverter side, and then you would wire it on 0.6 on the inverter side. So these are the wiring setup, and then you've got your positive and negative to the battery. So the positive and negative to the battery utilizes an MC4 connection. So on our next slides, Tafi will take you through the battery installation and commissioning. You will see how you wire everything up. And then since this system can be interconnected with a grid, so definitely you need a grid meter to monitor your export and control. In cases where you are not allowed to fit in, then you can control for export limiting. So Huawei inverters, they come with a meter, a smart meter, which is a Shin DTSU 666H. It comes with its own CTs, which are 250 amp primary winding. I'm sure residential, you won't get that far. Most residential inverters, they're around 60 amp, max 100 thereabout, right? And then so the communication between the inverter and the meter is through RS-485. So you'd wire your CT on our SOT on our right. As you can see, you've got your grid line coming through. You clip your CT at your mains incomer, and then to the meter, and then you get your L and N for live and neutral, and then RS25 you take it to the inverter on the same points where you want your RS25 for the battery. So then the inverter will be able to monitor your grid, and then the meter, it's a class 1, and it's compatible for export limiting. So the inverter can actually ramp down from max production to 0 within 5 seconds in cases for export control. So Tafi will take you through the commissioning setup. Do you have any questions in terms of wiring setup, product overview before we jump into commissioning? Okay. Since much of them are on the chat box, we'll just respond to some while Tafi takes you through commissioning. I'll quickly stop sharing my screen.
Once again, hello everyone. I hope you can hear me. Right. So we just need to go through now the installation for the Luna 2000 battery. So we've got a short video that we have that we cover that extensively. It's actually a video from the manufacturers. So we're just gonna need to play that video, and I'll share my screen. Then Brian had invited questions, I think, on the chat box there, with 1 or 2 questions that are there. The first one was, do you require the meter for a normal grid tied installation as well without the backup unit? Yeah, okay, Chris has already taken care of that. Yes, you still require the meter, because remember, our meter also are using it for export limiting. So even if it's a pure grid tie, you still need the meter so that you get all your load requirements, your load values, to say how much is your load. Then so you ramp up your inverter according to those meter readings. So you still need the meter. Then can the battery be charged by the utility supply? Yes. We'll see it when we're doing the setup. You can still set your battery to be charged from the grid. When you are preparing or you're anticipating a load shedding, you can actually say, okay, I don't have enough PV. Let me charge my battery to any percentage of your choice. Let's say to 100%. Then can the backup boxes be parallel to increase kilowatt output? No, you cannot parallel the backup boxes. Each inverter, you need a backup box for each inverter. And the backup box will be limited. The power that will be through the backup box will be limited to the size of that particular inverter. Then the other one, will the solar supply continue to contribute to the loads via the backup box during load shedding? Yes, that's correct. Even during load shedding, you should be able to get your PV supplying your loads. If the inverter is 2 MPPTs, can one string be configured without optimizers for the batteries? You can have 2 strings to your inverter. You can wire 2 strings to your inverter, and the other string can have optimizers, while the other one doesn't have. So that's correct there. If you buy a backup box now, will it be able to upgrade it for the faster transfer option at a later stage? Unfortunately, you won't be able to upgrade it to a faster transfer, because the upgrade that is coming is actually hardware. It's not only a software upgrade where you just need to upgrade the software, but it will be hardware in terms of the hardware architecture. The relays inside, there will be fast switching. So you can be able to download or to upgrade the software in order to get that fast switching. Right, so I'll quickly play and share my screen on the installation, on the battery installation.
The battery can be floor-mounted or wall-mounted. This video uses the floor-mounted installation as an example. Installation space. Use a level to check the levelness of the floor support. Mark the positions for drilling holes based on the floor support and marking off template. Drill holes by using. Install expansion bolts. Align the first battery expansion module with the floor support. Install the connecting pieces on both sides and tighten the screws. Secure the modules to the wall. Internal electrical connections of the battery. Install internal P cables. Connect the ground points of the modules one by one, and secure the P cables using ground screws. Remove the ejector lever delivered with the equipment. Remove the waterproof covers from the DC terminals using a removal wrench. Insert the internal positive and negative DC connectors into the positive and negative battery cascading terminals. Connect internal signal cables. When connecting signal cables between the power control module and battery expansion modules, install the terminals that connect two communications cables first. Then install the terminals that connect one communications cable. To remove the cables, reverse the above procedure. Remove the locking caps and waterproof rubber plugs from the shell of the communications terminals. Remove the waterproof covers from the communications terminals of the battery expansion modules. Connect signal cables between battery expansion modules in sequence. Install the waterproof rubber plug and tighten the locking cap. Connect the communications cable to the power control module and battery expansion module in sequence. Install the waterproof rubber plugs in sequence. Tighten the locking caps and secure the signal cables using cable clips. External electrical connections of the battery. Cable preparation. Connect P cables. Prepare DC input power cables. Connect the positive metal terminal to the positive cable. Crimp the terminal using a crimping tool. Connect the positive cable to the positive connector. Tighten the nut using an open-end wrench. Remove the waterproof covers from the DC terminals. Connect the DC input power cables. Connect the signal cables. Remove the shell of the battery signal terminal. Connect the inverter communications terminal. Connect the signal cables. Insert the terminal based on the silk screen number. Install the shell of the signal terminal. Install the waterproof rubber plug and tighten the locking cap. Install battery cables for the inverter. Insert the terminal based on the silk screen number. Install the terminal shell and waterproof rubber plug, and tighten the locking cap. Connect DC input power cables for cascaded batteries. Verifying the installation. Check the positions of the buckles on the shell. Place the protective cover close to the edge of the module. Move the cover outwards for a short distance and align the buckles. Push the cover inwards. Tighten the screws. Verifying the installation. If the indicators are both steady green, the battery is running. The indicators are both blinking green slowly. The battery is in standby mode. Check that the signal cables are S485 positive, RS485 negative, between the inverter and the battery are correctly installed. If the indicators are both off, the battery is in hibernation mode. Check that the signal cables EN positive, EN negative, between the inverter and the battery are correctly installed. If the indicator is green, it specifies the battery level. Each bar indicates 10%. Log into the Fusion Solar app using the installer's account. Tap Quick Settings on the home screen. Add a battery through Device Discovery and set the working mode. By default, the battery working mode is set to maximum self-consumption mode. Tap the question mark icon to view the detailed settings and set the working mode. On the home screen, choose Power Adjustment, Battery Control, to set the battery parameters and working mode. Choose Settings, Feature Parameters, and enable Off-Grid mode. The Grid Tightened Off-Grid ESS uses the backup box to switch the grid connection status of the inverter. When the grid fails, primary loads are powered in backup mode. After the grid recovers, the system automatically switches back to the grid tied mode. Replacing a fuse. When the inverter is faulty, there is a high probability that the battery fuse is damaged. Check whether the fuse is damaged or open-circuited, and replace the fuse if necessary. After powering off the connected inverter, turn off the DC switch for the battery.
Right. That was the short video for the installation there with all the installation instructions. So as we have already seen, the battery package comes up with all the cables made. So the connection is MC4 connections, which are easy, just plug in. So everything is plug and play there, and you don't have the risk of having loose connections, because it's just MC4 connections where you plug, the integrity of your connections is up high there. Then the communication cables are already made, joining the battery modules and up to the control module. So the only thing that you need to make is the DC cables from the control module going to your inverter. So that's the only thing that you need to make, and you can use your 6mm DC cables that you normally use for your strings. So the MC4 connectors are actually provided for in the package. You just need to crimp those ones, only for the DC cables running from the control module going to the inverter. So after everything is set up and you are done with the installation, now you need to commission. So the commissioning part, we have a video again that we have, and I'm gonna play it, then we'll just go through that one. So it has got snippets actually that you want, so we'll be pausing and explaining a few things. It won't take us more than 10 minutes, we'll be done. I'll quickly share my screen. Right, for the commissioning now. So what you need, the first thing that you need to do is to connect using your phone. You can use your phone to connect to the inverter. through the inbuilt VLAN dongle or through the 4G dongle. I know Brian has covered that, or through the VLAN FE dongle. So you just actually go to your Wi-Fi on the phone, you just switch on your Wi-Fi. So when you switch on your Wi-Fi, then you search for all the available networks, as can be seen there on the screen that I'm sharing. So I've just paused. So you can see that when you've searched the available networks, there is one that will be written SUN 2000 with that 1021, the one that I'm highlighting now. So this will be the serial number. Then the SUN 2000 is the name for our 6 KTL inverter with the serial number. So you log in to that actual network, inverter network that will be generated. So you are connecting. So you are connecting to that SUN 2000 network. Right. When you connect, after connecting to the SUN 2000 network, you go to your Fusion Solar app. So this is what you see when you open your Fusion Solar app. As you can see, the SUN 2006 KTL, there are 2 inverters with 2 different serial numbers. So you know the inverter that you are commissioning, the one that you are commissioning, the one that you want to connect it to, that's the one that you just click. So the app will actually be able to see all the inverters that will be online and communicating. So, but you want to log into one inverter that you want to commission. So you click that one. How do you see it? You just check your serial numbers, because this serial number should match with the one with the actual inverter that you want to commission. So there are actually 2 ways to connect to an inverter. You can use the default password, and it's written to be written on the side of your inverter, which is change me. So upon powering it on for the first time, every inverter, the default password that comes with the inverter is change me. So you can change this password to any password of your choice. Obviously, a password that you should not forget. Then alternatively, where I'm highlighting there, where it says connect, it's actually a function where you can scan your QR code. So the inverter on the side there, it will be having a QR code that you can quickly scan, then you log into that inverter. So the video is just rolling on. We want to see where you actually scan the QR code. Yes, then just one more important thing. So when you want to log into the inverter, it won't allow you unless your device location is turned on. So it will actually prompt you to turn on your device location. So the inverter will need authorization to access your location. When you've given that authorization, then you scan your QR code. Right, that's exactly how it looks like on the side of the inverter. On the right side of the inverter, there is that QR code and the password that will be written there in case you don't remember that the default is change me. So now we're just demonstrating, if you don't want to use the QR code, you can actually input your password, the change me password. Right. After that verification, password verification, then this is the page that you see, the main page that you see. So we've got the alarms, we've got the device monitoring, we've got the quick settings, the maintenance, the power adjustment, and the settings. So it's actually a simple process. So you quickly go to quick settings. Then when you go to quick settings, that's where you set all your basic parameters. So the first thing is basic parameter, where you put in the grid code. So in our case, you just select your NRS 09721. Then you just also make sure that the moment you select that one, obviously the voltage and the frequency come as default. Then you check your phone time. Then you should make sure that the inverter also has got the correct time. So you can actually synchronize your phone time so that the inverter gets the correct time by clicking the sync phone time button. This is where you'll be seeing different grid codes, and you should just scroll up and down to get yours, or you can quickly use the search engine on top. Just say NRS, then we get our South African grid code. Then when you are done, that's the only thing that you set in there. Then you click next. Then when you click next, it takes you to the device management. So the moment you click next, you don't need to manually be adding your devices. The system will start automatically searching for all the connected devices. So whatever is connected to that particular inverter that you have logged into will be searched automatically, and you will actually be able to see it on this page. As you can see there, automatically we have already managed to pick our power meter. Our dongle is showing, then our Luna 2000 battery is showing. Then the optimizers, they will do a quick, this one shows as default, then it will automatically start searching all the strings to see if you've got optimizers. Then when your communication cables are wired correctly, on the item that will be showing here, they need to show green on top, like the smart dongle. It shows that the communication is held. The power meter shows that the communication is held. Then on the battery, this one shows that it's not online, it's offline. So we're using this, when we're doing the video, we're using our model unit that is in the workshop. So we don't have PV, so we prefer to put our battery offline. Since we don't have PV, we are using a simulator. But in your case, when you're commissioning, this button should also, this pin should also be green, just like those, the power meter and the dongle, to show that it's held. So the optimizers will start searching automatically. It takes a little while, maybe three to 4 minutes. But in our case, we just jump that process. We just fast forwarded it. So now it has finished searching for optimizers. So if we had optimizers, they will start showing how many optimizers do you have in which string. So the good thing is everything is done automatically here. You don't need to do anything. Then when everything has been searched and found, then you just, what you need to do is press next. Then before you press next, you just wait for that message, processing message, to disappear, the one that says please wait. Right, the message has disappeared. The please wait message has disappeared. Then you press next. When you press next, now you are going to the third part of the quick setting option, the quick setting menu, which is the energy storage. I know we've covered it even on that Luna installation video. This is where you are defining the working mode of your storage system, of which the recommended one, the options that we have, their maximum self-consumption, the fully fed to grid, then the time of use, that TOU. So the maximum self-consumption, that's the recommended one, where you get most out of your storage system. You know, when the PV cannot supply and meet all the load requirements, then your battery starts discharging to supplement the power that is coming from the PVs. Then the time of use is when you strictly set it to say you want it to discharge only on preset times. For instance, you only want it to discharge from 7 p.m. for a number of hours that you prefer, let's say for 2 hours, for 3 hours, then the battery only discharge on those hours. So here you obviously want the maximum self-consumption, which is the one that is there and is the one that is actually the default one. Then the fully fed to grid, that's when you also want to be exporting your battery power. You're wanting to sell your power, during the day you've got enough PV, then you are storing it. Then during the night or whatever power you are selling it to other consumers to use. So this is when you're actually exporting to grid. Then when you are done with that, you press next. You now want to set it up. Yeah, let me just go there. This is when you now want to set it up on communication and networking. You want now to tell the inverter and configure your router to say for your remote monitoring, which network do you want to use. So when you have got a VLAN FE or using the inbuilt VLAN dongle, then you definitely need a router. So now you are selecting the home Wi-Fi. Then you select the home Wi-Fi. This is the Wi-Fi, which is the network that it will be using to log, and the one that will be uploading to the cloud, so that you can remotely access all the information and you can remotely monitor it. So you need to select that Wi-Fi, the home Wi-Fi. You are no longer selecting the SUN 2000, because the SUN 2000 does not have data that it can upload to the cloud, but it's just the one that you can use to log into the device locally when you are doing commissioning. But on this part now, when you are on the fourth item, where it's communication and networking, you need to choose the home Wi-Fi. That must always be active so that you can be able to access it remotely. So you just choose the Wi-Fi, then you put the password. Then when you put in the password, you see on top there, it's written, I've been authorized by the user to connect to the management system. You need to tick that one. Then the next one is monitor the PV plant through the management system. That one by default, it will be ticked. Then you see your inverter icon, the router icon, and the cloud icon. So all those lines should be green to show that there's a healthy and active connection there. Then that will be all with the quick settings. Then you click next. Then when you click next, finish, you actually get the list of all the devices that are connected. The first one is actually connect to management system, say success, which means we have successfully connected to the management system and you can be able to monitor your system remotely. Then the inverter there is ticked to show that it's connected to grid and the communication is healthy. The power meter shows normal. Then the optimizer, it says that it has completed the searching. The searching was complete for the optimizers. Then our battery is X because it shows that your battery is not communicating it's offline, it's not online. Then this is the battery that we just keep at the offices, so we will leave it offline so that we reserve whatever power is there. We don't want it to be discharging. So in your case, when on a real site installation, it should also tick green to show that it's online. Right, after the quick setting, there's only 2 more settings that you need to set. So we've done the quick setting. So the next thing that you need to do is to set the export control. Then the last thing will be the battery control, of which the battery control we've already covered it by the last part of the Luna installation, Luna 2000 installation video. So the next thing that you need to go to, you now need to go to settings. define how your system is going to be working. Do you want to, that's where you tell your system, do you want to export to the grid, or it's just for self-consumption, you don't want to be exporting? That's where you do your export control. Then so if you go to power adjustment, you see there's the third option, which is grid tied control. That's the one that you click and you do export control. Then it will prompt you to put the password. So you put that change me password if you hadn't changed it. But if you have changed it, then you put your new password. Then from grid control, you select the active power, right? Then this is important. Then on the active power, you've gone to, remember, I've gone to power management, you have gone to active power. Then on the active power, the control mode, you choose the power limited grid connected if you don't want to be feeding back to the grid. Then you leave the closed loop controller, I leave it as default. The limitation mode, total power, I leave the default. Then you go to the last one, the maximum grid feed-in power. So you have said your control mode, you are tied to the grid, but you want to limit the power that you can push back to the grid. Then you just come here, you choose 0. So which means you are not exporting anything to the grid. So that's how you do your export control. Then you're about to be done now. Then you quickly move to the right. If you go on settings, you get battery. This is where you can actually tell your inverter and configure it in such a way that you want it to be charging from the grid. So that's why it has got forced discharge. Then the forced discharge, remember, naturally, all your PV, you are using it to charge the battery. But the forced discharge, that's when you're actually saying, if I don't have my desired SOC, I want to use my grid to charge my batteries. So this is where you come to. Then on forced discharge there, if you click on that arrow where it says stop, you can actually say charge. The option that we have is charge, discharge. Then you set it. Then by default, the charge setting mode by default is duration, but you can change it to energy. When you change it to energy, you won't be dealing with the duration in terms of time, but you'll be dealing with the percentage SOC. I think we have demonstrated it here. Yes, you click that. This is stop. Then you choose charge. Then one way you change the duration. This is also important. Yes, the power point. You define your power. Our battery is 5 kilowatt, but it's 0.5 C, which means you can only put up to maximum, which is 2.5 kilowatt. Then this is our last thing. As I said, the charge setting mode, the default comes in on duration, but in reality, you don't want to be using time. You want a target SOC, so you come and change it to energy so that you deal with the percentages. You don't want to configure your system to say charge for 2 hours because you don't know what will be the SOC by then, but you can set now in terms of target SOC. So you just change the mode to energy, then you can put your desired SOC from 0 to 100. So after that, then you would have completed your commissioning. We have Brian to take over from this point.
Hello everyone. On the chat box, it seems you don't have any questions. If you have any questions, you can just unmute your mic, and then we can just short.